half adder, right? In half adder, if you would like to provide the sum, you have to use the minterms are 1, 2. If you would like to produce the carry, you have to use the minterms are 3. Minterms are number 3, right? Now, can you able to draw the circuit for this? Yes. For example, if I am going to have like 1 by 4 mux, sorry, it should be DEMUX as I am discussing the concept of De-Multiplexer, right? So here it will be I as input, and here 4 outputs are there, right? So to get the circuit value sum, what need to do? We have to take out 1, 2, and you have to make them OR gate. This is what you are going to get as sum. And this line, if you are going to give directly, you will get carry. Now, how many select lines are there here? S1 and S0. Try to observe, guys. If I am going to give the inputs as like 1, 0, 1, 0, which line is going to be activated? Which line is going to be activated? Here, all ones will be available. Ones will be available, right? Meaning that all i's input is already activated. If I am going to give 1, 0 as input, 1, 0 as input, the respective line, 1, 0 means what? 2. This line is going to be activated. When this line is going to be activated, meaning that its input is high. I can say that technically its input is high. And what about this input is low? This input is also low. This is also low. Right? On OR gate, when 1 is high, what is the result you are going to get? The result you are going to get as high. And here you are going to get as low. So means when you are performing 1 plus 0, sum will be 1, that you know, and carry will be 0, that you can understand. Right? This is the way you can able to use demultiplexers for the implementation of half adder. Similarly, if you would like to go with full adders, right? What about the sum values, minterms? Sum you are going to get the minterms for 1, 2, 4, 7. What about the carry? Carry will be minterms of 3, 5 and 6, 7. Now, can we able to implement with the help of 1 by 8 demultiplexer? Yes, we can easily implement with the help of 1 by 8 demultiplexer. The inputs are S2, S1, S0, like select lines, and input will be always high, and you are going to have multiple lines 4, 5, 6, 7, 8. I counted from 0, 1. Okay. Now this will be 0, 1, 2, 3, 4, 5, 6, 7. Now, according to the function, what you have to do here? By default, all will be enabled. Now, if I would like to make, the sum, what you have to do? You have to take out the 1, 2, 4 and 7. Right? This should be making it as 1 OR gate. This will generate sum. Right? Similarly, to produce the carry, you have to take 3, 5, 6 and 7 you have to consider. This will generate carry. Guys, whereas coming to full adder implementation of multiplexers, there you required two 8 by 1 multiplexers, two 1 by 8 multiplexers in order to implement sum and carry. Whereas coming to demultiplexers, with the help of only 1 by 8 demultiplexers, I can able to implement any number of functions. Right? Here the functions are like sum and carry for us. So I implemented 2 functions. I can call sum as f1 and I can call this as f2. That is the advantage of demultiplexers.